Alright, welcome. We're going to take a look at section 9.4 today. And to begin this 9.4 section, we are going to turn to page 35 and talk about a specific kind of graph or shape called a parabola. And a parabola is a curved graph that looks like this, like a happy face, or it could be upside down, more like a frown, like this. You could have other parabolas that are sideways, like this, but for now, the algebra that we're doing right now, you will not have any of these sideways ones. You'll only have either the ones that are going down or the ones that are going up. In a parabola, there is either a highest point here or a lowest point down here, and that point is called the vertex. The question for number 1 says, explain what is meant by the vertex. The vertex is the highest or the lowest point in a parabola. So go ahead and write that in there. The highest or lowest point in a parabola. Today we're going to be graphing these. And not exactly graphing per se, exactly, but more sketching these. Number 2 says, in your own words, explain what is meant by the line of symmetry. That's another part of a parabola. So say, for example, this is a parabola, and this is our vertex. Through the vertex, there is an imaginary line that goes straight through, like this, that separates the parabola in half, and it makes two mirror images. This side right here should be an exact mirror image of this side over here. So they should reflect each other. So how would I describe a line of symmetry? It's an imaginary line, that separates the parabola in half. Or into two equal parts, or into two parts that reflect. There's a lot of different ways you can describe that. I'll leave that up to you. Do you want to write what I wrote, or go ahead? Okay. Middle of the page, page 35. Here's what we have. Graph each equation. Give the coordinates of the vertex in each case. So notice that number 3 is already done. They want us to do two things. They want us to find the vertex. Here's the vertex, 0, 0. And then they want you to graph it. The graph is this right here. That's already done for us. So we're not going to do that one, obviously. For number 4, let me go ahead and explain what we're going to do. If you recall, on Monday, we had to look at something called the quadratic formula. It was a formula that looked like this. This is what we did on Monday. And this is called the quadratic formula. We're going to be using part of the quadratic formula today. We're going to be only using this part right here, the one that I circled. And that is going to equal x. So it's going to be negative b over 2 times a is going to equal x. So if you remember what we did on Monday, these formulas look like this. Ax squared plus bx plus c equals 0. And we took the a, we took the b, and we took the c, and we plugged them in to their appropriate places here, corresponding place where they fit. Okay, we put them all in there. But today, we're going to take only the A and the B, and we're going to put those into this formula. And whatever we get there, that's going to give us a value for x. And then we take this x and plug it back into the equation to find y. That may be a little confusing right now, but let me just go ahead and get started. Number 4, here's the problem. Y equals 3x squared. Notice that there's a y in this problem. Before we only used to have a 0. The 0 is like the y, so just ignore the y for now. This is a right here, the 3. 3 is a. There is no b. There is no c. So a is 3, b is 0, c is 0. So we're going to plug these in here and in here. And here's what we get. Negative 0 over 2 times 3, which is negative 0 over 6, which is 0. So that's x. Then you take that and plug it in here, which is going to be 3 times 0 squared, which will be 0 again. That's your y. So x is 0 and y is 0. That's the point 0, 0. So we're going to graph that, make a grid, your axes, and make a point at 0, 0, wherever you put 0, 0. So you put a dot at 0, 0. That is the vertex. That's either going to be the highest point or the lowest point. Now how can I tell whether that's the highest or that's the lowest? You go back and you look at what A is. See here? A is 3. If A is positive, this is going to be a parabola that will open upward. If A is positive, it's a parabola that opens upward. If A would be negative, then it would have gone down like this. But it's not. So it's the positive, and this is the vertex. The 0, 0 is the vertex. Now, how exactly do we know how wide or how narrow this is? Because it could go like this, or it could open up like this. Well, we don't exactly know at the moment. We'd have to plug in a lot of points, but for now, we're just sketching these, so we're fine with just making it as wide as we want it to be. Just go with the normal width for now. Number 5. A is right here. It's 1. There is no B. This is C. 4. So I'm going to plug it into this formula, negative B over 2 times A. So it's negative 0 over 2 times 1, which is 0. That's x. So I take this 0 and plug it in here, which is 0 squared minus 4. That equals y, which is negative 4. So my coordinate for the vertex is 0, negative 4. 0 for the x, negative 4 for the y. Make your x and y axis. And I have to plot the point 0, negative 4. 0, negative 4 is going to go down 4 from 1, 2, 3, 4 right here. Put a dot. That is the vertex. And then I have to figure out, is this going to be a graph that goes like this, or is this going to be a graph that goes like that? This is if the A is positive. This is if the A is negative. So I go back, I look, A is positive, so this is the graph that opens up. Now let's move on. Number 8. A is negative 1. B is 0. Plug it into the formula, negative B over 2A. I'm going to do it down on the left-hand side here. Negative 0 over 2 times negative 1 is going to be 0 over negative 2, which is 0. That's your x. Take this x and plug it in right here, so that I get this. Y is equal to negative 0 squared plus 4. That's just equal to 4. So my coordinate is 0, comma 4. Open this up. And then we have to put a point at 0, 4, 1, 2, 3, 4. And take a look at the fact that A is negative. If A is negative, this is a parabola that's going to open downward. It looks like this.